thank you. First thing, brand new logo, first official outing. Hooray, we have a logo. 3 spheres in a sphere, so quite cute. Second thing I was going to say is I'm making 3 mistakes that I tell every student of mine not to make. First, I talk about more than one topic. Second, I have way too many slides. And third, I just spent 30 seconds telling you that. So let's get stuck into it. So when we think about climate, so I'm giving you updates on 2 initiatives. One is the 21st Century Weather Center of Excellence, and another one is an international effort called Earth Virtualization Engines. And I'm going to try and combine them in 12 minutes. Good luck to me. So what's the big deal? So the big deal is when people think about climate, they think about pictures like this, including you and me. Right? This is the annual rainfall on the Earth, rains a lot in the tropics, rains a lot in the exotropics. What we quickly forget is that the rain's actually made by this. And these are small blobs of weather that are dynamically extremely active and that actually produce rainfall. And this is not just true in the exotropics where we all believe it because we have fronts, it's true in the tropics too. The tropics is not a bubbling pot of boiling water. It's anything but that. It has way more structures in that, it has weather. And that weather is what organizes this. So when we talk about climate change, we really need to talk about weather change. Because if we really want to understand how our climate's changing, if we want to know how this picture, not this picture is going to change, and anyone who read the IPCC report knows we don't know that very well at all, because the models are pretty woeful at reproducing this picture. The underlying cause must be somewhere in there. The reason we cannot reproduce this picture, and the reason we don't know how it's going to change, is somewhere in there. And so really our task is to move our thinking, and this is what the Center of Excellence for 21st Century Weather is going to do, to move our thinking from purely this sort of thermodynamic slow climate change with a bit of extremes on the end. And I don't mean this in a demeaning. Those are the 2 things we had to do first, but we've done them now. To what's actually happening to this. We're doing this, and I'm really rushing through this, but I'm giving a 20-minute talk just on this in the Atmospheric Working Group. So if you want to know more about the 21st Century Weather Center of Excellence, come to that. So we're doing this by having 3 research themes. One is on circulation change. So it's really, if you wish, our bread and butter, meteorology, oceanography, is how is the circulation in the atmosphere-ocean system changing? How does that couple to the land? How does the land change the circulation of the atmosphere, change the circulation of the ocean? Then we want to know, what does that mean for people on the ground? That's the weather change theme. So how does that actually translate into changes, things we care about? You may think beyond, one of the reasons we care so much about weather, and we will care more about weather in the 21st century, is we will make ourselves weather dependent as we have not been in the last 300 to 500 years. Why? Because we want to make all our electricity from the weather. Almost all of it anyway. So we will be incredibly weather dependent as a society, as an economy, as whatever you want to see us as a community. I like to see us as a community, but most politicians see us as an economy. We will be extremely weather dependent. And to underpin this, we have made the case that we really don't have the tools and that we need models that are much more credible in translating weather into climate. And we think that higher resolution is a pathway to do this. Since this is an ACCESS meeting, I just wanted to show you what we've written in our proposal. Part of it is based on reality, part of it is just dreams. So in 2026, we think we would like, these are all coupled models, a global coupled model at least 25 kilometers pushing 10, and a regional coupled model at about 1 kilometer. In 2028, we definitely want to be at 10 for the global system. We want a regional Australian domain, 500 meters, and a really large domain, ideally covering the Indian and Pacific Ocean, because those are the 2 oceans that we care the most about in Australia, and the Southern Ocean to the south, obviously, at about 3 kilometers. And in 2030, we want to have runs kilometer scale. Now, and regional a few hundred meters in the large domain at 1 kilometer. Now, we're not going to do scenario runs and things like that with those. We're going to do science with those. So there can potentially be relatively short runs that you will see come out of our research. The purpose of this, I had to put the slide in because there's a common misconception that you run a high-resolution model to provide high-resolution information. That's how we sell it to people who are not in our field. That's not the point in our center at all. We need these higher resolution models to improve the simulation of the larger scales. And that can be mesoscales or synoptic scales in the atmosphere, right? But the point is not to make rainfall at 1 kilometer. The point is that by allowing rainfall to occur in 1 kilometer in your model, the larger scales should get better. That's our goal. And we'll do science with the models. So I will skip this slide even though it's very interesting, but I think I will miss out on talking to you about Earth virtualization engines. This work that I just described to you very briefly and very poorly, but I'm very happy to expand over beverages of my choice. Is all these slides that are following come from Björn Stevens at the Max Planck Institute. There's an international activity that has similar, that there's a connection to our center, but also a connection to the Australian community that is still very weak. And I thought this is the perfect forum. The ACCESS folks are the perfect forum to hear about it. It's the Earth Virtualization Engines, or Eve. I'm introducing Eve, there she is, holding the Earth, virtual Earth in her hand, with many layers reaching out to the world. And I want to talk a little bit about this. So the key thing that we as physical scientists often get wrong is that there is more to climate change decision-making than the data we produce. We think we are the most important bit. We are an important bit. There's really, and so this comes out of social science, there's really data, information, and knowledge, right? Information is making the data useful, and knowledge is interpreting the data and learning something from it, actually. But the data underpins it. So climate's warming, there's a growing need for information. No one will disagree with this. But we also have this big increase, or this continued increase in our compute capabilities. And that actually, and we've learned that higher resolution models could potentially help us solve some of the problems that we still have in our climate models. So the knowledge leads to better data. And then there's another revolution that's going on that hasn't bypassed you. It's called JetGPT for some, but it's just this whole machine learning AI world is much smarter in extracting information from data, right? So we're making the data, we get smarter. So there's you could think of this as a rearrangement of this pyramid, where things are no longer on top of each other, but maybe much more closely connected. And Eve is trying to take advantage of this. The reason we feel it's necessary is, if you think about CMIP and any other model, big, large modeling project that currently underpins information, we are mispurposing what we built for research as an information service. And that's not going to end well if we keep pursuing that. So we need a new way of dealing with what we do day to day with climate modeling for the provision of information. That's not, you can read any CMIP paper you want. It will never say its purpose is to provide information to society. Its purpose is to underpin research. So then Eve is meant to be an international federation of centers. I better show you a picture because we don't have much time left. The vision of Eve is actually, there's two parts to it. One is centers that do this modeling, data assimilation, bringing observations and model together, and they are organized across the world. There's probably going to be a small number around the world. That's the vision. Say 5, in this picture it's 5, build around certain modeling systems, but equally important to Eve is this next layer, which they call the virtual Earth cloud, which is really, how do we take this data and make information from it? And how do we integrate the data generation, information generation, knowledge generation back to the data generation? And we think these Eve nodes will be doing this. And I have this last picture, which I really like, is sort of how, this is what we do. We generate data and we put it in a data infrastructure layer. But really, it's the people up there who want to use it. And there's a wide range of people, from us as research scientists, to consultants and policymakers, to citizens and lay people. They want to understand, they want to interact with this data. And we're going to here right now, where we make that sort of, we think by making it Cartesian rather than we've served society, and now society can get on with it. And then we realize that doesn't work, so now we make climate centers, climate service centers, and that's better because they help take this Cartesian stuff, which they understand. They don't understand this anymore, but they understand this, and they turn it into information. But really think about it. It's ChatGPT. It's the century of ChatGPT. What you really want to do is type a question into your computer and say, what are the maize crops in my country going to be like between 2050 and 2060? And you want an answer. We don't care, really, where the answer came from, but we care, and we want it to come out of this. So it's a huge challenge, but we really have to acknowledge that there's these layers, and we have to build each of these layers very carefully and connect them really, really well. And I stopped there. I told you I had too much. Thank you.